We're studying IGCSE chemistry and we're starting metal revision 1. In this class, before this recap, we studied everything about the periodic table. We looked at all the groups and trends. That's done. And uses as well, by the way. So that was a short class. It was a short chapter. Right after that, we will look at metals, because it's a direct extension of what we did in the last class. We looked at some metals. Now we're going to see how those metals behave as they behave, and why, let's say, why do they behave like they do, and how do we extract metals. So today's class, the agenda is first reasons, let's say, properties of metals, reactions of metals, and reactivity of metals. Now let's see how much we can do today, and then we'll do as much as we can. Now, can you see the book on the screen?
Yes,
Yes, sir.
But I don't think this is your book. This is
that's what it was looking very unknown, but yeah.
Yeah, that's A levels, right? This is the A level book. Forget that. Now, can you see this? This is your book.
Yes.
So classifying elements, and all of that is done. Now let's focus on metallic elements and alloys. Let's start from here. Now, Ritika, I want you to start reading from here.
Yes, sir. 14.1 Properties of metals. Physical properties of metals and non-metals. Most of the elements, 70 out of the total of 118 known elements, can be classified as metals. They are positioned to the left in the periodic table. The metals form a group of elements whose structures are held together by metallic bonding, a form of bonding discussed in detail in chapter 3. This type of bonding gives rise to many properties that the metals have in common. However, there is a wide variation in the level of these properties when we look in detail at different metals. For instance, many metals have a high density, example iron, but the alkaline metals, group 1, have low densities.
All right, stop. Now, that was just a basic introduction of metals. Metals lie on the left side of the periodic table. On the right, you have non-metals. Look, this is how it is. It's reactive metals, transition metals, other metals which are metalloids or semiconductors, metalloids. Then we have the non-metals right here. Hydrogen is a non-metal, by the way. It's not a metal. Hydrogen is a non-metal. Now we'll see some properties of metals and non-metals and how we can classify them. To start from the beginning. First thing we need to know about metals are the properties of metals. Start right in. First thing first, we'll look at physical properties. And we'll look at chemical properties. Now, first physical property is that it has good conductor of heat and electricity. Next thing would be malleable, ductile, sonorous, and shiny. 5. Let's join these together, malleable and ductile. 4th, high MP, and B2. Anything else? That's it. Pi MP. MP stands for melting point. And lastly, we have that they have high density. Now we're not classifying group 1 metals or not, group 2 metals, because that's different. We did that in the periodic table. These are the general properties of metals compared to non-metals. Now the chemical properties are that they form positive ions always. Metals form positive ions. They also make basic oxides. That is, they form basic oxides and take part in metallic or ionic bonding. Now finish writing quickly and then we'll continue. Neha, can you hear me?
Yeah, sir. Can you hear me now?
Yes, I can hear you. Good.
Yes, there was some problem in my mic.
So they're good conductors of heat and electricity. They're malleable, ductile, sonorous. So what is the meaning of sonorous? Right.
Sonorous is basically they make a sound when like struck or like hit or banged.
All right. Sonorous is basically that makes sounds. Yes. Good.
Yes.
Now finish writing quickly. Neha, Ritika, how much have you written?
Sir, I'm done.
Done. All right.
One
I
second,
am done.
I'm writing the last point. 1 second.
Yeah, me too.
Anas,
I started writing chemical.
Sure, done.
done.
Yeah, so done.
The first thing we'll look at is the structure, the metallic structure. Well, that's chapter 3, but we'll just recap it here. We will recap it over here. Metallic bonding in structure of metal. To see why and how they have these properties. Okay. Now, just a thing before we continue, please write the properties of non-metals right here as well. They are poor conductors of heat and electricity. They are brittle. They are dull. They have low melting point and low density.
Okay.
Well, instead of melting point, just write MP and BP. Melting point and boiling point. These guys form negative ions. They're the counter opposite of the other ones. They form acidic oxides, and they only take part in covalent or ionic bonding. No metallic bonding. Now the structure of the metals, finish writing quickly. The structure of the metals look like this. Well, I'll give you the notes which you need to write in the exam first. First, one thing is a lattice, which means regular arrangement. Lattice means regular arrangement. Right? Anyone, any doubts with this? What is lattice? A lattice
No.
is
Lattice is basically the arrangement of molecules in solids, and it
solid.
has high forces of attraction, and yeah.
Yeah, lattice basically means a regular arrangement, right? Regular arrangement. On the other hand, liquids have random arrangement. Gases have random arrangement. But lattice is basically regular arrangement of positive cations surrounded by sea of delocalized electrons. You need to write exactly these words for 2 marks in the exam. What does it look like? Well, this is what it looks like. You make the structure as well, because you will be asked to draw the structure in the exam. Now, all of these are positive. All of these are positive ions. And what we realize is there are electrons. Yes, yes. Anas, what is?
What does MP and PP mean?
Melting point and boiling point. This is what it looks like. You have electrons all around it. So it's basically a sea of delocalized electrons, randomly everywhere. You need to show at least a few electrons here and there. That will make sure that they understand it's a sea of delocalized electrons. And we don't have to show that. This is enough. But we'll put that boundary right there to show that it's a metal. So the main thing is lattice of regular arrangement of positive cations surrounded by sea of delocalized electrons, because they are not fixed. They're moving randomly.
Just give me 2 minutes to like write that down and like draw that.
All right. Now, okay, that's the structure. I hope everyone is catching up, right? Ayan, are you understanding? Neha, Ritika?
100%.
All right.
Yes,
So
sir.
if you have any questions, just ask me. I'm just moving on. You guys should focus on writing and also pay attention to the class. Now, next thing is, how does this structure give rise to these properties? Malleable, ductile, shiny, why? Right? So we look at that. Firstly, why are metals malleable or ductile? Question is, number one, layers of ions of, let's say, metal atoms can slide over each other. What does that mean? Well, if I have this layer right here, this top layer, it can slide over like this. So that basically allows it to bend. So if you can slide it, that means the whole shape can shift. Now you can shift this way, you can also shift it like this as well. That allows the whole thing to bend. Look how this whole thing is now malleable. So the whole structure has changed because of the layers being able to slide off each other. When force is applied. Right. Another thing is, why are they good thermal conductors, or why are they good conductors of heat and electricity? Why are metals conductors of heat and electricity? The reason is free, delocalized or free, both are correct. Electrons are present electrons carry heat and charge. Electrons transfer heat and charge. And let's instead of saying heat, let's say thermal energy and charge. That finishes all the properties of metals. Now the next thing we're going to focus on is
1 second. I haven't written why are metals malleable or ductile and why are metals conductors.
right. There's one more thing. Why are metals solid at RTP? What is RTP?
Room temperature and pressure.
Room temperature and pressure. Ritika, what is RTP?
Room temperature and pressure.
Room temperature and pressure. Room temperature is basically around 25 degrees Celsius, and that's basically your room. 25 degrees Celsius, and pressure is 1 atm. Now they won't ask you this. They'll just ask you why are metals solid at room temperature. That's what they'll say. Room temperature at IGCSE. All of that comes in class 11. Now why metals solid? Because of strong metallic bonding between cations and electrons. That's it. But that's an additional one which is not in your book, but they do ask you this in the exam. This is actually in chapter 3. Finish writing, and the next thing we're doing is called reactions.
Okay.
Can you write it, Shreya? Just a second.
The solids part is done. I'm writing conductors of heat and electricity.
Right. The reactions of metals. Neha, how much have you written? Anas?
Sir, I'm at the last line of the why are metals solid at RTP.
All right. Reactions of metals. The reaction of metals are with a few things. Acids. Well, firstly, water with steam, with right, with steam, water, with oxygen, and with dilute acids. That's all you have in your syllabus. Oxygen is basically air, but it doesn't react with air, it doesn't react with nitrogen in the air, it reacts with oxygen in the air. So we'll look at these in a second. Let's first start with the first one. Everyone finished? Ayan, have you finished?
I'm not. 1 second.
No,
Not yet, sir.
I started the why are metals malleable or ductile.
You started, okay, okay. Well, take your time, take your time. So everyone is here. That's fine. I'll keep writing, you guys should also keep writing. Now the next thing we are focusing on is oxygen first, right? First have oxygen. So first reaction, let's just say type 1. That's metals plus oxygen. They will say air in the exam. So you need to realize that air is basically oxygen in the air is what it's reacting with, not the nitrogen in the air or let's say hydrogen in the air. It doesn't react with those things, it reacts with oxygen. So metals plus oxygen or with oxygen. The reaction is first I'll give you the general formula. The general formula for this is, now it depends on which metals are we talking about. So we're looking at reactions of, let's say, group 1. First we're looking at group 1. Or never mind, we're just doing type 1. We look at group 1. Now this is the general reaction of all group 1 metals with oxygen. Whenever you get this, all you have to do is replace the M. What does that mean? Well, we'll look at that in a second.
So all of them balanced, like all of them balanced to 4m plus O2 leads to
Yes.
2m2O.
Yes, that's the
Okay, fine.
balanced equation. So
Fine.
you don't have to do any working on your side. All you have to do is memorize it and practice it. Not just memorize blindly. I don't like that. You should have this in your mind. First, practice, memorize, and practice as well. So we will do the practicing parts of it. So that's general formula for group 1. What about group 2? Well, let's look at group 2. For group 2, it's going to be M plus O2 gives us MO.
So wait, does type 1 mean like reaction type 1?
Yeah, reaction type 1. So we have the first one, oxygen, right? That's the type 1 of the reaction type 1.
Wait, aren't there 2 oxygens? I don't think group 2L is balanced.
Yeah, it's not. Now it's balanced.
Yep. Perfect.
Okay. So always for group 2, it's going to be like this. Now I'll ask you some questions before we move on, so you understand what this means. Just a second. Now, one thing, I will also give you the state symbols for these. Has everyone finished the top part? Anas?
I'm done.
Okay, let's go
Sir,
ahead.
I'm done too.
Good. So we
Yeah.
have this. Just have the state symbols here as well. So I'll just put them here for you. Have solid metals are solid. Yeah. Oxygen is gas. Yes. And oxides are also solid. Metal oxides are always solid, not gases or liquids. Now, examples of these. First example would be, let's say Na plus O2 gives us 2Na2O, 4Na right here. So 4Na plus O2 gives us 2Na2O. Now example 2 would be, for the side group 2, it would be, let's say, Mg plus O2. 2Mg plus O2 gives us 2MgO. How do we form these ionic equations? Well, don't just blindly know don't blindly follow it. Understand what's happening. So, well, oxygen is 2 minus, Na is 1 plus. All you have to do is take this guy here, I think you understand it, and this guy here. And that will give us Na, the 2 comes here, and O1. We don't have to write 1, so Na2O. Right? In the same way, we had Mg and O2 minus, 2 plus. So that will come here, this will come there. And you'll get Mg2O2. But our job is to simplify it. So Mg2O2 is the same as MgO. So the charges balance out. So MgO. We're done with that. Let's look at type 2.
For group 1, what does M stand for?
M stands for all the group 1 metals in us. So group 1 metals for this right here could be
So
Na,
Na is a group 1 metal.
Yeah, Na is group 1 metal in us. Yes. Look at the
And
periodic table.
magnesium is group 2 metal.
Yes, and there are almost all of these. There are many of these. You'll have to look at the periodic table. The first group is group 1. Yep. We'll look at examples in a second. Right now, let's focus on finishing this. Reaction type 2. Metals with cold water. Metals with cold water. Fine. We look at general formula.
Wait, there are two different reactions with cold water and warm water.
Yes, yes. Cold water, warm water. So warm water, it's steam. So hot water, cold water and hot water. Two different reactions. The reactions are going to be these. So we have M plus H2O, liquid. Cold water is a liquid, which will give us MOH, and here it will be MOH2. Something is missing, which is hydrogen gas.
Wait, we're not supposed to write the two.
Just a second, Anas. So we have, yep, this 2 comes here, and 2 comes here, and that is balanced, yes. These are this is the balance equation.
Two. What about group two? We don't have a two.
We don't have a 2 there, no. So whatever is on the board, that's what you have.
Sir,
Yes, Ritika?
sir, I don't
No, I don't think it's balanced, sir.
equation is balanced because there are 2 metals and 4 hydrogen.
I think it's 2 MOH.
Where?
Group
Oh
1.
yeah, group
Group
1.
one.
Yes.
Yep.
That should
Perfect.
be balanced. Yeah, that's better.
It is. It is.
Right here, look at this one. You have, look, the first one on us is the group 1. Lithium, sodium, potassium, rubidium, cesium, all of those. Second one, you have beryllium, magnesium, calcium, strontium, barium. So all you have to do is replace the symbol with the M. Now we look at a reaction with hot water. Wait, did I give you the observations for these reactions? I didn't know it.
No.
Just a second. Observations. For the first one, the observation is tarnishes, and because metal oxide layer forms. Okay, and some another let's say note would be metals are stored in oil to prevent reaction, to prevent contact with air. For the next one, the observation is, this is quite important. The observation is these guys fizzing, or just a second. Observation for group 1. Fizzing, effervescence, bubbles, floats, solid dissolves. These are all possible answers you can write in the exam. Now, let's remove fizzing and effervescence because they're the same thing. Effervescence, bubbles. Effervescence means fizzing, right? Now for group 2, it's a bit different. Let's write one more thing here, the violent reaction. or let's just say vigorous reaction. But for group 2, it's a bit different. Group 2. Let's just say bubbles and slow reaction. So group 2 do not react with cold water. They react slowly. On the other hand, group 1 reacts violently, vigorous reaction, right? Vigorous means fast or violent. Now for reaction with hot water or steam. Steam is the vapor form. So far we have done the liquid form of water. What happens if we get the vapor form? Or the gaseous form? Let's write that right there. So metal with gas, you won't get oxide anymore. You won't get hydroxide, you'll get oxide. So MO and M2O. Let's balance this now. You have H2O. That's balanced. 2 and 2.
Wait, for oxygen, is it going to be the same observation for both group 1 and group 2?
Yes, for its same initial metal oxide form. So that's common. But so it's not that different between group 1 and group 2. But for reaction type 2, metals with cold water, it's much different. Right. 12. Now, I haven't given you transition metals in these, but we won't look at that in cold water, but we do look at that in steam. Let's look at transition. So for them, the reaction is a bit different. Let's look at iron first, Fe3 plus. Another thing, these are all solid.
Isn't reaction 3 steam?
It is steam. Now zinc reacts similarly. So just right over here, transition metal, zinc and metal, they react in the same way. Zinc and iron. So the same equation will be for zinc as well. Ritika, Neha, Ayan, any questions?
No, sir.
Not really, sir.
I'm just giving you the information which you need in the exam, and then we'll practice this. But the practicing part is on your end, because we can only do so many questions in class. So there are worksheets, and there is the partial booklet as well, which you can get to practice partial questions chapter-wise. Now, I hope you understand that with water, hydroxide is forming, right? With steam, an oxide is forming. I need you to add one more thing here, which is the word equation. Just a second. For both of these, you should add the word equation.
Sir,
Yes.
sir, I have a doubt in the transition metals, the zinc
Ask.
and iron example.
Ask me. Speak louder a bit and go on.
The example of like the zinc and iron one.
Yes.
I don't think iron is.
Yeah, it's not balanced. Just a second.
Yeah, it's not balanced. Should be two, I guess, not three.
Just a second. Fe2O3. Uh, yes, right here. That's balanced. Okay.
Yes, sir.
Now this is for iron 3, by the way. Let's
Like
actually I
there
want
is
you
an
to see.
iron
Yeah,
two.
go on.
We also have like iron two, iron one, and stuff like that.
Yeah, we do. We do. Yes. Because it's a transition metal, it has variable oxidation states. I want you to change a few things here, all of you. This is Fe3O4 and this is 3. Make the changes. And zinc and iron react in the similar way. If it's with steam,
Wait, the oxidation number of zinc is 3, right?
now, yeah, it is, look, the oxidation number of zinc is 2 plus, all right? It is also 3. It changes. That's what we're trying to
Oh,
understand.
okay. So zinc 3 and iron 3 have this reaction, and then iron 2 and zinc 2 will have a different reaction, right?
No, but what we're trying to say is iron, whenever it reacts with steam, it will react only in this way. And zinc will only react in this way. It's steam. Just make sure, not with water. Water is different. So with steam, zinc and iron will react in this way. If they say zinc solid plus steam, you'll get the same reaction as this. Just replace the iron with zinc. Zn3O4, right? But this is uncommon. We'll look at this again afterwards. This reaction is very rare, but I'm still giving it here. It is in your book.
Okay.
Wait 1 second, I have to write that.
Write that, yes. Change the 3 and Fe3O4. This is only with steam. With water, it's different. Add that here as well for transition metals. Let's just do it for iron because that's the big one. So Fe,
I don't have space to write that.
write it separately below and write transition metal with cold water. Or just write type 2, then write iron below.
One second.
That's balanced. Now this is for iron 3 plus, this is for iron. Take that as an example. Or iron. This reaction is important, but again, they will only ask you for these ones. And it's very rare that you'll get this, but you can, so I'm giving you there. Now I think reaction 2 and 3 are done. The word equation, I hope you can
Are
give the word
there
equation on your own. Yes.
yeah. Are there any observations for reaction type 3?
Yes. Reaction type 3. Just a second. Okay, write it. The observation is hydrogen gas given up, which can be tested by lighted
Flint pop test. Yeah.
burning spirit, which pops. Now, by the way, just add one more thing in the beginning part, which is the bubbles. In this case, are also hydrogen.
Wait, I'm still rewriting the cold water one. Can you scroll up after you write that?
All right.
Thanks.
Never mind. Well, the bubbles are hydrogen gas, by the way. We should know that. We just add it right here. It's still.
Wait, what did we write for this? Oxygen, right?
Which one?
Before cold water.
Before cold water was oxygen. Now that's everything they can ever ask you. I'll also give you a diagram of how it's done. All right.
Did we make any changes to oxygen?
No, not at all. So how do we use? Let's say, how do we burn? How do we do reaction number 3? That's what we're talking about. I'll show you a diagram. Ayan, have you finished writing?
Not yet, sir.
This is how reaction is done. Reaction type 3. This will always come in the MCQ. We'll look at that in a second. First, finish writing this. Neha, progress?
Sir, the observations part, group 2.
Okay.
Wait.
Yes.
There's only 3 types, or is there a fourth one?
There is a fourth one. Yes. Fourth one is dilute acids. And then all the reactions are done.
Okay, all right. Actually, I'm doing like a different section for transition metals because it'll be more organized that way. Because I already wrote it and then we added transition metals.
It's fine.
So,
It's fine. But I just want I want all of this together. You can keep transition separate, but I need the
Yeah,
observations.
that's
the
all
group-
together. Yeah.
Yeah. All right. Transitions are an exception case. All right.
Yep.
They are very rarely asked, and we look at that again afterwards when we do questions.
Okay.
You have to draw the diagram.
No, you don't have to draw the diagram. Not this one. No. This one, no. Ritika, how much have you written?
Sir, I completed till the type. I completed the observation of type 3.
Type 3.
Yeah.
Well, that's amazing. Good.
I'm done.
You're done. All right. So I need students who are quite good at writing because this also increases your, let's say, habit of writing. That's good. Now, one thing is I can just tell you all of this. You have the notes in the GCR, but writing it in your notebook is a completely different scenario because then you're writing it yourself, you're memorizing, you're understanding, and you have to memorize it afterwards as well, right after class.
Yes, sir.
Now, these are actually the things which people get confused in, right? These questions come in the exam and they're like, how can I know that it's going to be 2 metal plus 2 water plus 2 MOH into 1 hydrogen, right? So there are rules for everything. There's a format for everything. By the way, this is not given in your book. So I try to give you a general format for everything. Now, Ayan, have you finished reaction type 2? Anas, have you finished reaction type 2?
Yeah, I'm done.
Yes, sir.
Just add one more thing in the observation right here. For group 2, right? Group 2, and add react vigorously. That's it. Group 1 and group 2. Well, we know that group 1 is reactive. Group 2 is less reactive. So with cold water, they don't react. They have a slow reaction. But with hot water or steam, they have a very fast reaction, vigorous. Just like group 1 in the cold water part. I need you to add one more thing. If you finish with that, add one more thing here. In metals with oxygen,
Mm-hmm.
you need to add that they make a flame.
They make a
Flame.
I don't
Burn
have
with
this.
flame. Just add the word burn with flame. Burn with colored flame. We look at that afterwards. The flame colors of all of these metals.
yeah. That's in chapter 11.
11, right? Done? Ritika? Neha?
Yes, sir, I'm done.
Burn with a colored flame. We look at colors later and react vigorously. Now, if you get any questions now, you should not be shocked where it's coming from. Everything is given here. It has every question will be from this information only. Now, the last type of reaction type 4, is metals with dilute acid. All right, just one more thing, which is now you have to add this. It's quite important. So reaction type 2, right? Look at these guys. Look at this guy. Look at this, guys. If you look over here, this is called a hydroxide. Can you tell me, are hydroxide acidic or basic? Ayan.
Basic because sorry.
Yes, sir.
Ayan. Are metal hydroxides basic or oxide or acidic?
Sir, they're
Hydroxide.
basic.
Basic. Hydroxide are always basic because they give OH minus ions. So just add one line here as a note if you have space. Solution becomes
I don't have
solution. Becomes,
Okay. So I have a question.
ask me.
If it was a non-metal hydroxide like calcium's a metal, wait.
Chlorine hydroxide.
Yeah, chlorine hydroxide or something like that.
It doesn't
So
exist.
so non-metals don't form hydroxides, do they?
No, they don't. Never.
Okay.
Because
So
both of these are negative. Look, Cl minus, OH minus. They won't join together. They need Cl minus and H plus. Does it make sense?
Yeah, right.
Solution becomes alkaline. That's important. Write that and we're done with everything. Now, reaction with dilute acids. Please leave some spaces. Don't try to keep everything together because I may ask you to add a few more things afterwards. Right? So we don't miss anything. The reaction type 4 with dilute acids. Now, okay, what does that mean? Well, let's look at the general formula. Before we look at the general formula,
the
Just 5 minutes, alas. The word equation. First, write the word equation, which is metal plus acid, gives us. Now, the dilute part here is just a formality because in your exam, they're only going to ask you dilute acids. Okay. So the only acid you're getting is dilute acid. Metal plus acid is going to give us salt plus hydrogen gas. General formula are first group 1, then we have group 2. For group 1, it's M plus HCl as the dilute acid. You can have different types of acids, by the way, but HCl is what we're looking at. Or in the first type, reaction type 4, write dilute hydrochloric acid. Or dilute acids and put bracket HCl. So M plus HCl will give us MCl plus H2 gas. This will give us MCl2 plus H2 gas. Now it is missing, this will give us 2. That's balanced. And for this, we need 2M, 2. That's balanced. And let's finish writing this, then you can go.
Okay, what about observations?
Observations, right? Observations are, again, bubbles, right? You have a gas being formed. This is a gas. This is a gas. This is aqueous. Aqueous. This is.
What does aqueous mean?
Aqueous means dissolved in water. What does it mean, Anas?
Dissolved in water.
Water. So it's like a solution, not liquid, not pure liquid. It's a solution mixture. The observation for this is fizzing, or let's just say effervescence. Effervescence. And bubbles, solid dissolves, and solution becomes neutral.
Both of them have the same observations, right, sir?
Yes.
All right. All right. Okay.
Spelling is not correct. Now it's correct. Effervescence. Yep. That's it. So both of them have a common observation. Now we look at another ones, a few examples separately for transition metals. With iron and Zn. This is iron 2. This is zinc 2. That 2 right there is telling us the charge of the iron. Fe plus HCl plus HCl gives us FeCl2, ZnCl2 plus H2 gas plus H2 gas.
Sir, the first formula, the iron formula is not.
Ritika, yes, tell me.
Nothing, sir.
All right. You can ask me anything. Feel free to ask me. Neha, any questions?
Wait, can you go up a little?
All right.
Yeah, that's. I was writing group 1 and 2.
That's it. There's nothing else. all the reactions are done. I'll just give you one thing you need to understand, which is not in your current book. It's an old book. I'll open it and I'll send you a picture. Just a second. By the way, if you can be honest with yourself and you can honestly memorize all of these, then there's no way you're losing any marks in this chapter. It is that simple.
So if you're done writing, can we leave?
Just a second. No, there's one thing remaining.
Yeah, you can just tell us.
This one. Can you see this?
Yes.
Neha, I want you to read the first three.
Okay. Sodium, air, burn very strongly. Okay, wait, it's all the three of them. So sodium, calcium, magnesium. Air burn very strongly in air to form oxide. Water reacts with cold water to give hydrogen. Dilute HCl react very strongly to give hydrogen.
Right now, that's for sodium, calcium, magnesium. But after that, you'll realize that aluminium reacts less strongly with air. It does react with steam. It doesn't react with cold water. Okay, and zinc, iron, aluminium react less strongly with HCl. These guys react very strongly, but this is less strongly. These guys react with cold water, but these only react with steam. Now, lead, copper, they do not react with water or HCl. Silver, gold, they don't react with any of these. So that is something you need to keep in mind. Please take a screenshot of this table.
Okay, can we like print it and stick it in our notes?
That would be much better. That would be important. Now, I'm not asking you to write this right now, but you have to take a screenshot right now.
Okay, done. Shall we leave?
Done? That's it. Yeah, you can leave. Take care. Goodbye.
Thank you. Bye.
Sir.
Ritika, stay for a second.
Yes, sir.